To understand heap sort, we first of all need to know what is a heap. To understand what is a heap, first of all, we should know what is a tree. Now, tree is another kind of data structure, and especially we are talking about binary trees only here. So, binary tree में क्या होता है? There is a node, a root node, and there are children of the node. Since it's a binary tree, the maximum number of children that any node can have is 2. So, any node can have maximum 2 children. Then again, the nodes can have maximum 2 children, and so on and so forth. Now, there are two conditions of a heap that we are having. There are two kinds of heap also, max heap and a min heap. Whatever max heap हो चाहे min heap हो, whenever we are building the heap, हम level wise building करते हैं. इसका क्या मतलब है? If I want to insert some elements in the tree, just for example, एक list है मेरे पास. This is any list, sorted, unsorted कोई बात नहीं है. इस लिस्ट को मुझे बाइनरी ट्री की फॉर्म में दिखाना है, तो जैसे जैसे एलिमेंट्स आ रहे हैं 5, फिर लेफ्ट पे इंसर्ट होगा, फिर राइट पे इंसर्ट होगा, फिर लेफ्ट के लेफ्ट चाइल्ड पे, फिर राइट के राइट चाइल्ड, लेफ्ट का राइट चाइल्ड, then you come up with child and there are no more elements, so you stop here. So you are inserting from the root का लेफ्ट चाइल्ड, रूट का राइट चाइल्ड, फिर उसके लेफ्ट चाइल्ड का लेफ्ट और राइट चाइल्ड, then right child का left or right child. So you do the insertion from left, 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 and this is the procedure that you are creating this tree. This is known as an almost complete binary tree. Almost complete binary tree. तो heap में जो है वो हम almost complete binary tree ही use करते हैं. So that ऐसा कभी नहीं होगा कि हमें इस लेवल पे 4 के चिल्ड्रन मिले हुए हैं लेकिन 5 का राइट चाइल्ड ही नहीं है. ऐसा नहीं हो सकता. This cannot happen. So you have to have 8 के children now. ये possible है क्योंकि अभी it has to be the next in the order, so that we can number the elements. This is the first element in the list, second element, third element, fourth element, fifth element, 6, 7, then 8, 9, 10, 11, so on. So we have the numbering in this tree. इस numbering से what are we getting is parent of any node I is the floor value of I by 2. For example, this is the list. मुझे parent of 6 निकालना है. This is 1, 2, 3, 4, 5, 6. I4 का parent निकालना है मुझे. अगर I4 है तो 4 by 2 is equal to 2 will be the parent. 2 पे 4 है, 4 will be the parent of 6. मुझे 1 का parent निकालना है. Supposedly 1 is 5. 5 by 2 is 2.5. Floor value is 2. That means again 1 का parent 4 है. So the point of keeping the list in this manner is कि हम list को as it is we can pick the numbering. Now the parent is I by 2 for any node I. Left child of ith node is given by 2 multiplied by I. Now supposedly I want to find what is the left child of 4, or say what is the left child of 8. Now that means left child of third node I want to find. This is 2 into 3, 6. Sixth location पे क्या है? 3. 3 is the left child of 8. Supposedly I want to find the left child of 5. 5 is at location 1. So 2 into 1 gives me location 4. Location of second element, which is 4. 4 is the left child of 5. Similarly, if I want to find the right child of I, it is found by 2 multiplied by I plus 1. So right child of I can be found by 2 multiplied by I plus 1. अगर मुझे 5 का right child निकालना है, that means 1 into 2 plus 1 gives me location 3. Third location is 8. 8 is the right child of 5. Supposedly I want to find the right child of 4, which is 2. So 2 into 2 plus 1 gives me 5. Fifth location is 1. 1 is the right child of 4. So कितनी भी लंबी list हो, the same formula is there. Parent of I is floor value of I by 2. Left of I is 2 into I. Right of I is 2 into I plus 1. Now please note, these formulas are for beginning with 1, not 0. So when you convert them into C and C plus, The properties of a maximum heap and a minimum heap are simply that in the case of a max heap, parent is always greater than equal to the child node, and in case of a minimum heap, parent is always less than equal to the child node. What do I mean by that? Supposedly I'm having any data. So supposedly this is a heap that is created. This is a min heap. मिनिमम हीप का मतलब है पेरेंट जो है वो नोड चाइल्ड नोड से कम होगा, एंड दिस प्रॉपर्टी शुड बी सेटिस्फाइड ऑल थ्रू आउट द सब ट्रीज ऑफ द हीप. सो 10 इज द पेरेंट, 20 and 11 are children. Now it is not necessary कि 11 20 से छोटा हो, nothing like that. 20 and 11 are children, they are less than 10, they are sorry greater than 10, satisfied. Children greater than parent, satisfied. Children 15 and 70 are greater than 11, satisfied. This is a minimum heap. If I take similar elements, if I want to create a max heap, then the root is always greater than the children. I have to make sure that I am having the root which parent greater than the children. So I am having parent which is greater than the children. Always, this is a condition here. There is no other option. So for the same elements, I have created a max heap where parent 80 is greater than 70 and 30. 70 is greater than 20 and 11. 30 is greater than 15 and 10. So for every node having children, parent will always be greater than the child node. Greater than or equal to the child node. This is the basic property of a heap. Max heap or minimum heap. So we use heap data structure. We use heaps to sort a normal list of array, which is known as a heap sort. So we'll understand what is that. What do we mean by the heap sorting? We'll understand heapify also. Let us try to do that. I hope this much is clear to all of you. So let us try to understand a procedure called as heapify. Max, we are taking as max heap because क्या हो रहा है? Max heap में या min heap में, whatever ways, the topmost element is the largest or the topmost is the smallest. So at least एक element I know is sorted. So I can keep reducing the size of heap, pick up the root and keep saving it in the right position. That is what we do in heap sort. 80 को pick करा, उसे बाकी की दोबारा हीप क्रिएट कर दी, फिर टॉप मोस्ट रूट को पिक करा, फिर हीप क्रिएट कर दी. दिस इज व्हाट हीप सॉर्ट इज. लेट अस अंडरस्टैंड द प्रोसीजर. आई एम फर्स्ट राइटिंग द प्रोसीजर फॉर मैक्स heapify. I am taking a list A and till I elements I need to heapify the list. It is going to look a bit difficult, but it is not, because we'll do few examples on heapify, so don't worry on that. Let us try to see the algorithm. First, I calculate the left of I and the right child of I. I calculate these in N and L and R. I जो भी node है जहाँ से heapify start करना है हमें, I am creating the left and the right children in L and R. Now, if left and right children are available in the size, then that means I'm checking if L is less than equal to heap size of A, that means left child should exist तभी तो, and A of left child is less than A of I. Now left child जो है I से छोटा, A of left child is less than A of I. That means what is the largest here? I is the largest. In this case, I is the largest. Sorry, largest एक temporary variable है जिसमें I am storing I. Else, I am just calculating कि given 3 nodes में से सबसे बड़ा कौन सा है. अगर पेरेंट सबसे बड़ा है तो कुछ करने की जरूरत ही नहीं है, लेकिन तीनों में से सबसे बड़ा कौन सा है अभी सिर्फ वो निकाल रहे हैं. तो लेफ्ट चाइल्ड छोटा है अगर पेरेंट से, तो लार्जेस्ट पेरेंट है, वरना लार्जेस्ट लेफ्ट चाइल्ड है। अब राइट चाइल्ड के लिए सेम चीज चेक कर रहे हैं। इफ राइट चाइल्ड हीप साइज में एग्जिस्टिंग है एंड a of right is less than a of largest, sorry, is greater than a of largest, अगर राइट चाइल्ड लार्जेस्ट से बड़ा है दैट मीन्स मुझे लार्जेस्ट को चेंज करना है, देन अपडेट लार्जेस्ट टू बी राइट चाइल्ड। नाउ लार्जेस्ट फाइंड कर लेने के बाद हमें नोड्स का लार्जेस्ट पता चल गया। अब मुझे देखना है अगर लार्जेस्ट पेरेंट है तब तो देयर इज नो नीड टू हीपिफाई। इफ लार्जेस्ट इज नॉट इज इक्वल टू आई, पेरेंट के इक्वल नहीं है, तो मुझे हीपिफाई करना पड़ेगा, दैट मीन्स इट इज नॉट satisfying the properties of the heap. Then what should I do? I should exchange the parent with the largest. So exchange a of I with a of largest and again call heapify, max heapify on the list A. Now I am checking with the largest element as the node, जिसके लिए मुझे हीपीफाई कॉल करना है। सो आई रिकर्सिवली कॉल दिस इज द मैक्स हीपीफाई प्रोसीजर। लेट अस टेक एन एग्जांपल एंड लेट अस ट्राई टू डू द प्रोसीजर एंड सी कि हम क्या कर रहे हैं। सपोजिटली देयर इज अ लिस्ट, रेड पेन इज नॉट वर्किंग, सो आई एम जस्ट टेकिंग अ लिस्ट। Supposedly there is a list I'm taking. I'm intentionally taking a list where heap sort property is not getting satisfied, so that I will use the heapify procedure. Now till here the heap has been, this is a tree which is given to me, and in this we are initially calling heapify for a comma 2. So I is equal to 2. This is 1 2 3 4 5 6 7 8 9, the number of element go live. So I'm calling for 2. 2 is here, I have to check from here. So let us see what will happen in this case. I calculate the left of I. I is 2, left of I is 2 into I, left of I is 4, right of I is 2 into I plus 1 is 5. So left of 2 is 4, right of 2 is 5, left child, right child, calculated. अब मुझे देखना है heap size क्या है यहाँ पे, 9 is the heap size. Now heap size here is 9, 9 elements है, so the 9 is size. L is 4, 4 less than 9, that means existent है, it exists. अब मुझे चेक करना है 8 is less than a of I, 8 is now a of L, that this element is less than a of I. Is it happening? No, I cannot see that happening. मुझे इन तीनों में लार्जेस्ट निकालना है। आई एम बिगिनिंग विद द 2, 2 के लिए मुझे हीप की प्रॉपर्टी चेक करनी है, सो उसके चिल्ड्रन से ही चेक होंगे ना। सो इन दीज आई एम चेकिंग 8 लेस देन 6, नॉट ट्रू, सो लार्जेस्ट इज इक्वल टू, ये तो नॉट ट्रू हो गया, दैट मीन्स लार्जेस्ट इज इक्वल टू L, तो लार्जेस्ट में 4 आ गया, इंडेक्स ऑफ 8। अब चेक कर रहे हैं अगेन, R is 5 less than 9, size of the heap, yes. A of R which is 5 greater than A of largest, A of largest is 5 greater than 8, no, largest remains 4. अब चेक करो A of I which is A of 2 is 6, if largest is equal to, sorry I चेक करना है हमें, तो largest is 4, I is 2, they are not equal, मतलब heap की property satisfied नहीं है, parent is not greater than the children, तो जो सबसे बड़ा child है उससे I exchange, so I perform the exchange on these two. Since the parent is not greater than the children, I exchange with the largest, so 8 comes here, 6 comes here, and I am again calling heapify on A comma largest, this time is 4. उस चाइल्ड जिससे एक्सचेंज करा है उसके लिए दोबारा हीपिफाई कॉल करा है चेक करने के लिए, ठीक है। सो दिस इज अगेन कॉल्ड हियर। अब अगेन 6 2 से चेक हुआ और 7 से चेक हुआ, 6 is not greater than 7, तो रिकर्सिव कॉल में 7 will be the largest. 6 और 7 जो है वो एक्सचेंज होंगे. 7 will come here, 6 will come here, and again heapify will be called for this location 9. अब 9 के चिल्ड्रन जो है वो हीप साइज से बाहर चले जाएंगे, so the recursive call will stop. Since there are no children of 9, if condition में आप नहीं जाओगे, so largest will be equal to I, ये condition true नहीं होगी, so you will stop the recursive call and the heapify will happen in this manner. Now the left side is heapified, if you see. Now if I am again calling supposedly heapify on a comma 1, this time I am calling a heap. Now 1 is already heapified, if you can see, so I need not call it there. So I am trying to call for a comma 3. थर्ड नोड चेक कर रहे हैं हम. 15 तो बड़ा ही है ना 8 और 4 से, तो हम थर्ड नोड के लिए चेक कर रहे हैं. 4 उसके चिल्ड्रन है 3 और 7. 7 इज द लार्जेस्ट आउट ऑफ द 3. लार्जेस्ट में 7 मिलेगा. 7 और 7 इज लोकेशन इज 7, फोर्थ लोकेशन इज 3. आई एंड लार्जेस्ट लोकेशन आर नॉट इक्वल. नॉट इक्वल मतलब एक्सचेंज. सो एक्सचेंज द पेरेंट विद द लार्जेस्ट चाइल्ड and again call heapify for exchange node. Heapify 4 के लिए call होगा, no children, so it would not happen. Now this is in the heap. It is now satisfying all the properties of the heap. This is what the max heapify procedure is. Same thing happening. Let me take one more example to clear what is the max heapify procedure. Supposedly I am intentionally taking a heap which is not sorted properly, and instead of taking it 1 2 3, supposedly I am taking supposedly this is a created and I have to check. So I initially call heapify from a comma 2, element 1 2 3 4 5 6 and 7. So 7 is the size of the heap. a comma 2 के लिए I am calling, so 2 node के लिए I have to check heap की property set satisfy हो रही है या नहीं. 2 10 and 11 children में से largest is 11. Since 11 is largest, 2 and 11 will be exchanged. I will exchange this 2 and this 11. These would be exchanged. 11 comes here, 2 comes here, and heapify will again be called for this location. That means a comma 5 के लिए it is called again. When it is called for a, so after swapping these two, heapify will again be called for the location 5. Now left child of 5 is 5 into 2 is 10. 10 is not lying in the right child is 11. 10 and 11 जो है वो heap के size से बाहर है, तो heapify if वाली conditions में जाएगा ही नहीं, it will stop. Again supposedly I am calling heapify for a comma 3. The left child here becomes 6, the right child becomes 2 into 3 plus 1 7. So out of 3 1 and 5, the largest being 5, we will swap these two. 5 comes here, 3 comes here, and after exchanging the values, heapify will be again called for 3, जिसके children नहीं है, so we stop. So now we have the heap which is all properties satisfied. This is the heapify procedure. Now let us see a small build heap procedure. Using this heapify procedure, अगर कोई भी list given है, so how do I build a heap? So let us see the build heap procedure now. I am having build heap, एक given list है. I am just building a heap from the given list A. What do I have to do? I am calculating the heap. I am just running the loop. So supposedly I am calculating the heap size as length of A. Not required वैसे technically. Whatever is the length of my list. So I am running a for loop for I which is equal to the floor of length of A by 2. Which is अगर आप C या C++ में implement करेंगे तो automatically integer value में वो floor ही लेता है. So length of A by 2. Till where? Down to 1. Last लास्ट के हाफ से शुरू कर रहे हैं। इसका मतलब क्या है, लास्ट नोड पे जो है वहां पे तो हमारे कोई चिल्ड्रन, ऐसे पेरेंट्स तो है नहीं जो, इफ आई एम क्रिएटिंग अ हीप, सो व्हाट एम आई डूइंग इज कि इस नोड पे कोई चिल्ड्रन तो है नहीं, सो स्टार्ट फ्रॉम दिस लेवल ताकि हम चिल्ड्रन क्रिएट कर सके। सो आई एम बिगिनिंग फ्रॉम लेंथ ऑफ a by 2 down to 1. What am I doing? I'm calling do max heapify. I'm calling the heapify procedure here for a comma I. This is the build heap procedure. That's it. Let us see a quick example of this. Supposedly I'm having a list 5, 4, 10, 15, 6. I have to build the heap out of this. So if normally I create a tree, it is 4, 5, 4. It is going to be inserted as the numbers come. But this is not a heap. So how do I create a heap? To build the heap, I is length of a by 2. Length is 1, 2, 3, 4, 5 elements. So the length is 5. 5 by 2. I initially begins with 2. So I call heapify for this is 1, 2, 3, 4 and 5. Currently आप ऐसे समझ लो मुझे heap बनानी है. So I am going to create a heap. Currently heapify is being called for a of I, which is 2. This list is currently created like this. Automatically I want to create a heap of this. So what do I do is, I'm calling heapify for the first child, the left child initially. So here when I'm calling it for 2, 4, 15 और 6 में से सबसे बड़ा check होगा heapify में. They will be exchanged so that the new tree will be 15, 5, 15, 4 and 6 and then 10. Now here again max heapify will be called for this node. No children, so it will stop. You come back to build heap. लूप में I will be reduced to 1. 1 के लिए दोबारा max heapify will be called for a comma 1 now on this list. Now 1 is 5. The children are 2 and 3. As you can see, 5, 15 or 10 में से 15 is the largest. So you will swap these two so that now you get 15 here, 5 here, 10 here, 4 and 6 are here. So once again you will be calling a heapify on the position where you have changed to this position. You will be calling heapify. When heapify is called here, 5, 4 and 6 में से 6 is the largest. You will be swapping the values so that you have 15, 6, 10, 4 and 5. Again heapify will be called for 5, but there are no children, so it will stop. So after these 4 steps, this is now a heap. You have built a heap from a given list. So these are the steps that you are having for a given list. अभी भी heap build हुई है. Heap is not a sorted list. Understand that. Only the parent is greater. The only thing we know about heap is कि largest element topmost है. Build heap is clear to all. Build heap is clear to all.
Yeah, ma'am.
So after I have built the heap, now I need to do the heap sorting. अब heap बनाने के बाद heap sorting में क्या करना है? Let me take the same example. I'm having 15 here, then I have 6, 10, 4 and 5. That means ये stored कैसे हैं? ऐसे stored हैं 15, 6, 10, 4 and 5. I have to sort this list. To sort this list, what I do is I swap the last element with the first element. I am swapping the last element with the first element. क्यों? Because I know this is the largest. And I remove this from the heap. So what I do is 5 comes here, 15 comes here. So that this 5 comes here, 15 comes here, and I reduce the size of the heap. That means I eliminate this from the heap. तो अब मुझे यहीं तक के लिए I have to do the same thing. I will call heapify procedure now. I will call heapify on this node जिसे हमने exchange करा है पहले तो. I will rebuild the heap here and I will do the same thing. फर्स्ट और लास्ट को एक्सचेंज करेंगे. अब मुझे सबसे लार्जेस्ट मिल गया हीप सॉर्ट से. नाउ आई विल कॉल heapify फर्स्ट ऑन द फर्स्ट एलिमेंट. नाउ व्हेन आई एम कॉलिंग heapify, 5, 6 और 10 में 10 is the largest. They would be exchanged. So the new elements will be 10, 6, 5 and 4. Once again heapify will be called for 5 जो उससे की exchange हुआ है. No children, it will stop. Once again you do the same thing. Pick up 10, exchange it with the last element. That means 10 and 4 are interchanged. Now 2 elements have been sorted, and since 4 comes here, 10 comes here, delete this from the list. Again call heapify on 4. Now you have 4, 6, 5. Call heapify on this. Out of them 6 is the largest. So 6 comes here, 4 comes here and 5 comes here. Again call heapify on this. No more children not required. Do the same. Last element से swap कर दो 6 को. 5 comes here, 6 come here, delete it from the list. The position of 4 is not correct in this. I have done something wrong. So 4 had come here, then 4, 6 and 5 were there. So now I am saying exchange 6 and 5 so that 6 comes here, 5 comes here and delete this. अब 4 और 5 के लिए, इन दोनों के लिए again I have to call heapify. Now the list left is 5 and 4. 5 is greater, no need to call heapify. Remove 5 also. Exchange so that only 4 is first exchange. 4 becomes 5 becomes the root. Delete this so that 5 is here root. Delete this. Now again once again you are the 5 was here, sorry, 4 was here. You exchange them so that 4 comes here, 5 comes here. Again the last element is here. Now you have the sorted list. So and it is a very small procedure. I will write the heap sort, then you will understand. What we are doing is picking the last element and swapping it with the first element, because first element is the largest. तो उसे last से swap कर दिया, फिर first वाले के लिए दोबारा से heapify call कर दिया. So let us see the heap sort procedure now. अच्छा lengthy है, I agree, but why are we doing it then? We will see the complexity analysis. First, let us write the algorithm for heap sort. So the heap sort procedure will first of all build a heap out of a given list. When I am given a list, I will call the build heap procedure that we have seen earlier. After doing that, for the, I am beginning with the length of A, whatever my list is, down to 2. What do I have to do? I have to exchange the last element with the first element. So do exchange A of 1 and A of the last element, which is the whatever I am having currently, which is in I. Currently this last element is in I, right? And I am also reducing the heap size. Heap size of A is equal to heap size of A minus 1. Now I am calling max heapify. जहां से एक्सचेंज करा है तो 1 पे एक्सचेंज हुआ है, सो आई एम कॉलिंग मैक्स heapify फॉर A, 1. दैट्स इट. बस इतना ही है हीप सॉर्ट प्रोसीजर. सो इफ यू लुक एट द 3 एल्गोरिथम्स, ड्राई रन आपको लेंथी जरूर लगा है, बट इफ यू लुक एट द 3 एल्गोरिथम्स, there is a build heap, there is a max heapify and there is heap sort. That's it. Now let us try to look at the complexity of the algorithm. If the algorithm is clear, I'll give one more example to run the algorithm later. Let's first look at the complexity of the algorithm. How much time is build heap going to take? Build heap was calling heapify. build heap was calling heapify. Now you will be very astonishingly intrigued to know, अब क्योंकि हम इस फॉर्म में सेव कर रहे हैं, तो जो हमारा build heap प्रोसीजर था वो length by 2 से स्टार्ट हो रहा था, ध्यान था आपको, and then we are calling heapify. So I'm actually dividing my problem into a size of n by 2, n by 2, n by 2, and then calling. So if whatever length, whatever I'm having, I'm dividing, since it's heapify, I'm dividing the problem and then sorting. So the procedure is going to take of the order. Now there are build heap is supposedly taking this for loop. Build heap is also supposedly taking of the order n time, linear time to build the heap. This for loop is again taking of the order n time, n minus 1 technically. I से length से लेके 2 तक चल रहा है. Then I am calling this max heapify. How many times is this max heapify called? अगर हम 1 से शुरू कर रहे हैं, सपोजिटली वर्स्ट केस है, सारे गलत लगे हुए हैं, तो 1 2 3 4, इवन फॉर सो मेनी थिंग्स, द नंबर ऑफ लेवल्स इन द ट्री, उतनी ही बार मैक्स heapify विल बी कॉल्ड. Or I can say that this max heapify is called log n times. From the complexity analysis we know that the number of levels will be n upon 2 raised to the power k is equal to 1 तक जाएंगे number of levels. K is the number of levels, so k comes out to be of the order of log n. So max heapify is called log n times. The loop is running n minus 1 times. Thus the complexity of heap sort comes out to be of the order n log n, which is way better than of the order n square. ये worst case complexity है. Worst case में भी हमें n log n time ही लगेगा. So in any case, heap sort is better as compared to the other algorithms. In the worst case for sure. And it is also giving us these largest in the first location every time if it is a max heap, or the minimum in the first location every time if it is a min heap. After building the heap, once the build heap is done, I will be having the smallest or the largest in the first location, depending it is a max or a min heap. So we have the heap sorting procedure where I will be only taking of the order n log n time.